Have you ever noticed how remarkably flat our solar system is? All the planets orbit in roughly the same flat plane, almost like toppings sitting on a giant cosmic pizza. But it didn't start out that way. Long before there were planets, our solar system was a massive, chaotic cloud of gas and dust. As gravity pulls that massive cloud inward, it starts to spin. To understand what happens next, picture a chef tossing a ball of pizza dough into the air. As the dough spins, the outward force stretches it from a round blob into a wide, flat disk. Out in space, that exact same physical process turns a chaotic, spherical cloud of stellar gas into a neat, flat disk where planets can eventually form. Because of the basic physics of rotation, spinning cosmic systems naturally settle into a highly organized, flat plane. But in recent years, astronomers have discovered something that defies that rule. They found planets in other star systems that orbit completely sideways. It's as if a stray pepperoni decided to hover vertically, looping over and under the crust of the pizza. Astronomers call this measurement a planet's orbital inclination. That's just the specific angle at which a planet's path tilts away from the solar system's flat equator. Usually, that tilt is close to zero, but these newly discovered planets are tilted all the way up toward 90 degrees. At 90 degrees, a planet dives directly over the north pole of its sun, plunges straight down through the equator, and passes under the south pole before coming right back up again. The spinning pizza dough physics that forms a star system simply cannot produce a vertical orbit like that on its own. A planet born in a flat disk should naturally stay in a flat disk. Since a perpendicular orbit doesn't happen by itself, astronomers realized something else had to be out there. An unseen outside force is actively pulling these planets out of their lanes and breaking the universe's traffic laws. So, what kind of cosmic force possesses the power to grab an entire planet and yank it completely out of its natural, flat path? The answer lies in a fascinating physics concept known as the Kozai mechanism. You can think of it as the ultimate sneaky neighbor effect in astrophysics. It turns out, these sideways planets are rarely alone. They usually share their star system with a massive, hidden companion lurking at the outer edges, often a giant planet similar to Jupiter. This massive neighbor is much too far away to ever physically crash into the smaller planet. But because it is so incredibly heavy, it casts a wide, invisible net of gravity, exerting a relentless pull from billions of miles away. As the smaller planet races around its star, that distant giant neighbor acts like a subtle magnet, gently but constantly tugging on its path with every single lap. Over time, this constant tugging forces an unusual trade-off. First, the smaller planet is forced to trade its perfectly circular orbit for a highly squished, eccentric oval shape, stretching further and further out toward the bully. Then comes the second half of the trade. As the orbit becomes more and more stretched out, the angle of the orbit itself slowly tilts upward. Like a seesaw rising into the air, the entire path tilts until the planet is flipped completely sideways. This patient prank unfolds over millions or even billions of years. Little by little, the steady pull of gravity warps the planet's trajectory. We usually think of gravity as the glue that holds solar systems together in neat little rings. But given enough time, that same gravity acts as a disruptor, capable of entirely rewriting a star system's architecture. Entire galaxies follow the same pattern of gravitational bullying. We can look at the structure of our own Milky Way to see the evidence. This diagram shows a cross-section of our galaxy. The dark middle band is the thin disk, where stars follow designated flat lanes. Above and below is the thick disk, a puffed-up cloud of older stars, buzzing around at wild, messy angles. Just like those sideways planets, this puffed-up galactic souffle tells a story. Our galaxy didn't grow up perfectly isolated in an empty void. At some point in its history, it was bullied by a massive neighbor. Billions of years ago, smaller rogue galaxies physically crashed directly through the Milky Way, acting a lot like a bowling ball striking pins. This graphic maps the resulting chaos. The immense pull from the crash scattered millions of stars out of their flat lanes, sending them crisscrossing everywhere. Knocked into steep, tilted angles, diving far above and below the plane, they became permanently trapped in wild orbits. So, while spinning gas and dust means the universe's default state is flat and orderly, nothing in space exists in a vacuum. The relentless, sneaky tugs of distant gravitational neighbors guarantee that the cosmos will always be beautifully, perfectly messy.